So hi everyone, welcome to today's webinar, Programming with LLMs in R and Python, brought to you by Jumping Rivers. I'll start with just some introductions. So I'm Myles. I'm a data scientist working at Jumping Rivers. I've been working for the company for about 4 years now. And in terms of what we do, we're a data science consultancy and training provider. So we basically provide support to a wide range of client companies, be that in academia, public sector, government, private sector. And we basically provide support on anything that's data science related. So we've worked on a number of projects in R, Python, and Shiny. So these could be machine learning projects or developing web dashboards. We also offer a package validation service. So we've worked with a number of groups from pharma, insurance, and government on the topic of our package validation. We also have a cloud engineering team who can provide you with support and maintenance for your POSIT products. So POSIT Connect, POSIT Workbench, POSIT Package Manager. And we offer various services, including health checks, and these vary from basic to enterprise level. We are also a training provider. So we teach over 50 different courses covering all things programming from beginner level right up to more advanced topics. So yeah, we've got courses across R and Python and various other tools and softwares. And we're also proud to partner with POSIT, Databricks, and Validated Cloud. So if you'd like to find out a bit more about us and what we do, you can check out our website. It's jumpingrivers.com, and you'll find more information there. Just to mention as well, somewhat related to today's webinar, which is AI themed, we do actually have an AI conference coming up in June. So this is AI in Production. This is going to be running on the 4th and 5th of June. It's running in Newcastle in the Catalyst. So this is actually the building where the Jumping Rivers head office is. It's just at the top of this building here. So it's a nice chance to come to Newcastle, and it's going to be 2 days. It's going to be a day of workshops followed by a day of talks, and it's basically covering everything from applied AI to machine learning. So there'll be talks on taking off-the-shelf large language models and incorporating those into your day-to-day workflow. And on the machine learning side, everything from training your model to deploying your model to the cloud. So basically creating enterprise applications that are based on AI and machine learning. So all these topics will be covered. So I've got the link here to sign up. Please do stay until the end of the webinar, because I do have a discount code to share with you, which you can use to get 30% off the registration fee. So I will show you that discount code at the end of today's session for anyone who's interested, and I'll give you a QR code then as well, so you can get registered. Great. So that's the housekeeping out of the way. So we can get into the actual content for today's session. It's a really amazing turnout today. I'm seeing 94 attendees in the room, which I think is probably one of the biggest turnouts we've had for these webinars. So yeah, thank you all so much for coming today. It really means a lot. So in terms of what we'll be covering today, we're going to be starting with an introduction to large language models, covering the strengths and weaknesses of LLMs. Then we will go into how to connect to an LLM API from R and Python, and then how to send user and system prompts, how to format your prompts so that you get back a structured output. So if you're working on an R program or some analysis in Python, it's great if we can interact with an LLM, but it's even more useful if we can get the outputs from the LLM in a tabular format that we can actually work with programmatically. So we're going to see how to do that today. And then we'll be finishing by showing how to encode images and PDFs. So how to use LLMs to analyze images, PDFs, so that could be plots, it could be reports, and all of this. Throughout today, Just in case it's your first time on a webinar call on Zoom, so we don't have the typical chat option for this, but you do have a Q&A button. So if you go to the bottom of your screen, you should see a Q&A button. And if you click that, you can just post any questions that you have throughout the session. Some questions I might answer sort of in real time as they come, but I'll make sure I've got about 10 minutes left at the end of the session to go through any questions that I've not had time to go through. Okay, so yeah, please use the chat to keep asking questions throughout today. Great. So we can get stuck in now. So to start with, I'm going to just begin with generative AI basics. Now, I'm assuming that most of you, if you're coming to this webinar, it means you probably have an interest in large language models. Perhaps you're already using them, or perhaps you're thinking about using them, but you sort of don't know where to start. So yeah, although today is going to be largely talking about how to interact with LLMs in R and Python, we're going to be starting with just the basics behind generative AI and how it actually works. So how are large language models priced? What are the strengths and weaknesses of large language models? All of this is going to be relevant throughout today's session. So yeah, we'll start with an overview of some of the more popular large language models, and we'll go through some strengths and weaknesses. So first of all, what is a large language model? Basically, it's a type of generative AI model. So what that means is it is an AI model that is designed to generate stuff. In this case, that is text. So the way it works is we give it a text input, and then we get back a text output. And large language models are very knowledgeable. So they've been trained on massive data sets of text. That includes books, articles, websites. They've been trained even on open source code. So they've got a really broad knowledge of basically just anything that you could find on the internet. They're also very good at imitating specific writing styles. So you've got sort of fine control over the tone of the response that you get back from the LLM as well. So how does it actually work? Because again, all of this is going to be relevant if we're going to be using LLMs in our Python code. So the way it actually works is we provide the LLM a text input, and this is called a user prompt. So here the user prompt could be what happened in 1066. And what then happens is this gets converted into what we call tokens. So a token is like the smallest unit that you can have in an input prompt. So it's basically how an LLM breaks down text into individual components. So in this case, each word becomes its own token, but then you'll notice the question mark becomes a token because that's really important context. The fact that this is being phrased as a question, that's going to affect the tone of the response that we get back. And numbers are generally split up as well in interesting ways. So 1066 is actually being split up into two numbers here, into two tokens. But yeah, that's essentially what's actually going on. And these tokens are then converted into a numerical representation. This is called vectorisation. Because at the end of the day, a large language model is still a mathematical model. So even though we are interacting with LLMs using text, they are still mathematical by nature, so they still expect to receive a numerical input, and from their perspective, they're just giving you back a numerical output. It's just that we've got these vector mappings or vector embeddings that we can use to convert between the text representations and the numerical representations. So we give it an input, this is converted into tokens, and then that is converted into a vector representation, which can now be processed by the model. The model then gives us back a sequence of output tokens. So in this case, it's given us in 1066 a major succession crisis in England and so on. And again, the output is split up into tokens. And what actually happens is the model outputs one token at a time. So it starts by outputting this first token in, and then the next one, and then the next one. And by the end of it, you end up with quite a coherent looking paragraph of text, which could almost have been written by a human. So it's all based on sort of weighted probabilities. Basically, because we're asking it a question, there's only a finite number of words that it can begin its response with. So in 1066 makes sense as a way to start that response, or it could be the year 1066 could be another way to start that. And so, um, but yeah, it's essentially using probabilities to kind of choose which token to give us next. So because it's doing it one token at a time, and it's kind of based on some randomness as well. It means every time we give an LLM the same input, it's always going to give us a different output. And this randomness, or apparent randomness, this can make LLMs feel more human in nature. At the same time, though, it means that they're also quite difficult to program with, because we're very used with computer programming. We're very used to having the same input always giving us the same output, right? Because a computer is, at the end of the day, is as we've known them. They're just designed to solve calculations, and for the same input, you'd always expect to get the same output. LLMs do not follow those rules, though. So it means if we're programming with LLMs, we have to be familiar with this inherently random nature, and we have to think of clever ways to basically force it to give us back a consistent response. So we're going to be going into that sort of topic as we go through the session today. So we've seen user prompts, and we've seen the output that you can get back from an LLM. Then we've also got the system prompt. So the system prompt is basically our way of controlling the behavior of the LLM. So at the very start of the conversation, we might provide some initial instructions. So here it could be you provide your answers as a witty university professor. So we're kind of specifying the tone in which we want to get the response. You might also provide some detail as to how big a response you're looking for. So are we looking for it to be, more than 100 words, or do we want to keep it to less than 20 words to save on costs? So yeah, that's essentially what the system prompt is for, and we'll be coming back to that as we get into the code demo. So the next consideration then is the models and providers. So there are lots of different models available for us to use, and these are all offered to us by various providers. So some of the more well-known providers include OpenAI, Anthropic, and Google. And each provider offers a wide range of models that all come in different versions and different builds. So OpenAI, they are responsible for the GPT models. So here we've got GPT 4.1. Here's 4.1 Nano. Anthropic are well known for the Claude models. So you've got Opus 4, Sonnet 4, Sonnet 3.7. So they all come in different flavors, and each flavor will have its own version number associated with it. And then with Google, we've got the Gemini models. So these could include 2.5 Flash, 2.5 Flash Lite, 3.0 Pro. So you've got this wide range of models to choose from, and it's not always straightforward to know where to start. In general, most models will include a cheaper, more lightweight variant. So in the case of Google Gemini, Gemini 2.5 Flash Lite is the cheapest model available for Google. That means it's probably going to be the fastest to run because it requires the least computational power. But at the same time, it might not be as knowledgeable because the model doesn't have as many parameters. It doesn't have as much complexity. So it might not be as knowledgeable as a more advanced model would be. But it's the cheapest, so it's quite nice just for experimentation. But then you might want to go to something like Gemini 3.0 Pro if you're building an enterprise application and you need it to be accurate and you need it to give good responses. So yeah, there's always a balancing act between, do I go for the cheaper, more lightweight, but potentially faster model, or do I go for the more heavyweight, expensive, and more knowledgeable, but probably slower model? So there's always a kind of balancing act between the two. In terms of how they are priced, again, there's a wide range of pricing depending on which model you're using. The pricing is generally calculated in millions of tokens, and it can be anywhere from 40 cents right up to $75 per million tokens. Input tokens are also priced differently from output tokens. So output tokens, from what I've seen, are generally about 4 times as expensive as input tokens. And that's because the service that the model is providing to you isn't giving you that output. So that's why the output is what is charged more. So it does mean you can get away with having quite a big input prompt, and it's probably not going to ramp up costs as much as you're expecting it to, because it's really the output that's going to dominate on the overall costs. Another thing, though, to bear in mind is that you will actually accumulate tokens quicker than you realize over the course of a conversation, because the model has access to all of your previous user prompts throughout the conversation history. And it means every time you ask a new question or you pass it a new user prompt, all of the previous conversation history is going to be bundled in with that user prompt, and all of that's going to be counted as input tokens. So it means every time you send a new prompt, the number of tokens that you're accumulating is increasing cumulatively each time. So it's passing in the full conversation history every time you pass in a user prompt. So it does mean over the course of a conversation, you are going to amass tokens faster than you expect. And so it's a good practice to initialize a new conversation if you don't actually need to keep the history of the current conversation. So that's just a very good tip, if you're looking to save any money on this. That said, though, if you set a spending limit of £20 or $20, say for like the month, you'll probably find that it takes a long time before you get even close to that number. So generally, they are still quite cheap to use at the end of the day. And yeah, just to go through some strengths and weaknesses, and then we'll get into the programming aspect of this webinar. So in terms of some strengths, LLMs, they're widely known to be very good at generative tasks. So that could include generating emails and reports. Some people even use LLMs to generate CVs, which I'm not recommending. But yeah, you can use them for all sorts of things. And they're also very good at summarizing text. So for meetings, LLMs are very good for summarizing the meeting transcripts. If you're preparing a presentation based on a report, you could use the LLM to basically pull out what are the most important bullet points from this report, and then those could go into your PowerPoint presentation. So they're quite good for these sorts of tasks. And then when it comes to data science specifically, they're very good at code generation. Although they're going to probably be better when it comes we're talking about R and Python packages that have been around for a long time. So like pandas for Python or dplyr for R. AI copilots, they're going to know about these packages. They're probably going to be very helpful in suggesting code for you to use. If we're talking about more recent packages that maybe have only come out in the past couple of years, it's less likely that the LLM will have heard of that package. So sometimes you might need to provide some additional contextual information about the packages that you're using, or what your project is actually for, and that sort of thing. They are also very good when it comes to data summaries. So there's a tool called DataBot that I've been experimenting with recently. That's quite cool if you haven't seen it, where you can basically give it your data and it will produce detailed reports, and it'll pull out the interesting features of the data, like how many missing values are there, how should you treat those missing values, all the considerations that would go into those initial data exploration steps for like a machine learning project. LLMs are very good at advising you on those initial steps. And then they can also be incorporated into data dashboards as well. So if anyone here has used Shiny for web dashboard design, you can incorporate a chat box into your dashboard, and you can even incorporate features where you can allow the user of the web app to explore the data in the app via the AI chat box. So it's quite a nice way of replacing all of those toggles and filters and buttons that you would normally have in a web app, and replacing that just with a chat box, basically, where you can just ask sort of human readable questions and get back a nice summary. So yeah, there's all sorts of uses when it comes to data science tasks. And then just to go through a few weaknesses and some common pitfalls. So the big one is hallucinations. So all large language models are prone to hallucinations, and this is where they will present incorrect information to you as though it is fact, and it will do this in an overconfident way. A lot of models are trained to sound as knowledgeable as possible, and it means they will often just give you an answer that sounds plausible, because you're more likely to keep paying for a product that appears to know a lot of stuff. But it means you have to be very careful with fact checking the information you're getting back from a large language model. So yeah, if you find that you're getting a lot of hallucinations, it could mean that the model you're using just doesn't have the contextual knowledge for the the domain specific area that you're working in. So you might need to provide some more information through the system prompt, or you could make use of something like retrieval augmented generation or RAG to give it access to domain specific information that it could make use of. There are some other weaknesses too. So large language models typically have quite outdated knowledge. So if you were to ask an off-the-shelf model, what is the current date? It will often just say, I don't know the answer to that, or it will give you the date on which the model was produced. Yeah, in general, I should say there are some, if you're using like a cloud console for Claude or for Google Gemini, say, it probably will be given access to additional tools where it can look up this real-time information. But if you're just interacting with the raw model just on its own, basically, from R or Python, you'll probably find it doesn't have access to this real-time information unless you give it access to that information yourself. They're also known to be poor at logical reasoning. So in general, I would avoid using LLMs to solve maths problems. I could give the LLM the ability to produce the say the SQL query code that I could use to to get a summary of my data set, but I wouldn't trust it on its own to go and calculate the means and the averages of my data for me, because they're just notoriously not great when it comes to logical problems. I've heard that they're not good at Sudoku as well and chess. So yeah, they're very knowledgeable about stuff, but when it comes to numbers, it might just give you a number because it looks plausible, but it might not have actually calculated that model and that number, properly. So yeah, it's just worth being very careful with that. And then we do also have a token limit. So as you have a conversation with an LLM, you can approach a token limit, at which point it's no longer able to store the full conversation history. So it might have actually forgotten about the initial prompts that came up in that conversation. So that's another thing that's just worth being wary of. But yeah, so we've gone through all of the setup now. And we are now going to go on to the programming aspect of the session. Like I said earlier, I'll probably come back and go through all of the questions at the end of the session. So I'll make sure we've got some time left over at the end for that. If you do have any questions, make sure to keep posting these into the Q&A chat box, and I'll go through these at the end. So do keep the questions coming if you've thought of any. Okay, great. So we'll go on to the programming side now. So how to program with LLM APIs. So we're going to see how to connect to an API from R and Python, some good practices for writing user and system prompts, and how to format your prompts to get a structured output. So the two packages I'm going to use for this part of the demo are the ellmer package for R and the chatlas package for Python. So these are both maintained by Posit. And so Posit, for anyone not familiar, it's the company that's responsible for RStudio. So any R users here, if you've used RStudio, then you've used a Posit product. And Posit also maintain packages like Shiny for web dashboard development, and Quarto and R Markdown for report generation. So yeah, these are both packages that are produced by Posit. They're free and open source, so really easy to install and work with. They have complete parity with each other when it comes to features. So anything you can do in ellmer, you can do in chatlas for Python. And they also support connecting with lots of different providers and models. So if I've got these links here. So if I go to the ellmer documentation, you can see the full list of providers that are supported by ellmer, and it will be the same list of providers that's supported by chatlas as well. Now, one caveat is that even though these models will give you the ability to connect with these providers, even though these packages will allow you to connect with these providers, you will still be responsible for acquiring an API key for which to with which to send queries. So if you don't have a valid API key on your machine, the API won't accept user prompts and system prompts. So that should be saved as an environment variable on your machine, and this is the thing that actually gets billed. So when you're paying to use a model, you're basically paying for the number of tokens you've used for a given API key, essentially. So there are freely available API keys, though, for certain models. So Google Gemini has a free tier that you can use if you're just looking to get started. Claude also has a free tier. So if you're just looking to have an experiment or play around, it's relatively straightforward to acquire an API key. You can just search Google Gemini console or Claude console, and that'll have all the instructions for setting up an API key. So how to actually connect to an API. I should say an API, when I talk about an API, I just mean the cloud interface through which we're interacting with the model, okay? So it's like the go-between between our Python code and the large language model that we're interacting with. So we first have to choose a provider and model. So we might go with Google Gemini, and to set up a chat object in ellmer, it's just the chat Google Gemini function. To set up a chat object in Python, it's the chat Google class that we can use. And once we've set up a chat, then we can begin sending user prompts and also creating system prompts. So I'm just going to hop over now to my positron session. So this is where I've got the R code for this demo. And I'm going to start with R and just go through some examples of some cool things you can do. And then I'll switch over at the very end of the session to Python and just show you that you can do all the same things with chatlas as well. I'll just go to the filled in code demo as well, since we're a little bit short on time today. So to connect to a large language model in R, and the first thing I'm going to do is use 2 seconds. I'm just going to restart my. There we go. All good. So, okay, so I've used library ellmer to load the ellmer package, and to set up a chat, I'm using the chat Google Gemini function from ellmer. I'm passing in a system prompt, which is here you answer in approximately 100 words or less. So again, if you're looking to save costs, it's a good idea to set like a maximum size for a given output prompt. It can be a good idea if you don't want the LLM to go off and give you a full essay when you're just looking for a couple of sentences. For the model, I'm just using the cheapest available model, basically. So Gemini 2.5 Flashlight. It's good enough for this demo. And I think it's important to show that all of the stuff we're covering today, you can do this using completely free tools and free tiered models. So you can go away and have a practice with this if you're interested. So I'm just going to run that now to initialize my chat object. And in order to send user prompts, we can use the chat method. So it's chat $chat, and then we give our user prompt as a character string. So we can do what happened in 1066. And at the bottom here, we can see the output that the model has given us. So looks very plausible, looks pretty accurate. So that's great. And then we can also ask who was the first person to set foot on the moon. That's another example. And here it's given us Neil Armstrong, and it's given us the year that happened. You'll notice that large language models, they will have a tendency to give you more information than what you asked for. So even though I just asked for who was the person, it could have just given me his name, but it's given me all this extra information that maybe I didn't require. And there are ways to keep that output down to a minimum, which I'll show you a bit later in this session. We can try asking it some other questions as well, just to check its real-time knowledge. So as part of my role at Jumping Rivers, I organize a series of data science meetups in the northeast of England. It's called the Northeast Data Science Meetup, and these run every 3 months. So I might try seeing if Google Gemini has heard of the Northeast Data Science Meetup. And it gives me what looks like quite a plausible response. It's sort of saying it's likely a community gathering for people interested in data science. But crucially, it doesn't actually know. It doesn't have it doesn't actually have access to this real-time information. So here it's just telling me I don't have access to this real-time knowledge. When I've asked it the same question in the past, sometimes I've received a much more confident answer. Where it sort of almost pretends that it knows exactly what this meetup is and when it runs and how it works. So it is worth sometimes just asking the model to be honest, if it doesn't actually know the correct answer. So yeah, that's an example maybe of somewhere where a large language model is less intelligent. So anything that's kind of real time, or it could be just a lesser known event or conference that's taking place. It might not have all the details immediately to hand. And then, yeah, we could try asking what's today's date as another example. And again, it doesn't have access to real-time information. And that even includes the current date. So this particular model that I'm using, it says here that its knowledge cutoff is early 2023, and I cannot browse the internet to check what today's date is. Now, there are ways that you can give your model access to tools with which it can look up this real-time information. But yeah, it's just worth noting that if you're just taking an off-the-shelf model, it's going to have quite limited knowledge when it comes to real-time stuff. So moving on to system prompts, we can provide more detail in our system prompts if we wish. So here I've given a slightly bigger one. So we're saying you're a university professor who makes history fun and exciting. You respond in bird metaphors, and you provide answers that are 100 words or less. So okay, so that's a interesting system prompt, and we can then reinitialize our chat using that system prompt that we've just given it. And we can ask it again what happened in 1066, and you'll see that the actual tone of the response has changed based on that system prompt. So we can see it's giving us bird-related metaphors, just as I'd asked. There we go. We've got sparrow boarding off a hawk. So yeah, so you've got a lot of control over the tone, and you can make it lighthearted. You can make it more professional. You've got a lot of fine control in that respect. Now, so far, all of the responses I've been getting are unstructured. What I mean by unstructured is that we're just getting back a big paragraph of text. Okay, and that's essentially it. So that's great in that it's given us all of the information that we've asked for, but at the same time, it's not really something that we can work with programmatically. You know, we can't take a character string and then do meaningful maths or statistics with that in R. So it'd be really nice if we could format our prompts and get back a tabular response instead. So getting back like a table of information, which we can then analyze and work with as part of our analysis workflow. The good news is that this is actually relatively straightforward to set up. So we could try initializing a new chat again, and let's go back to that question I asked earlier: who was the first person to set foot on the moon? So again, it's Neil Armstrong. Now, what if all I wanted was the name, the age, and the nationality of the astronaut who set foot on the moon? You know, I don't want all this extra information that it's given me. I just want those three things. So we can do this by specifying what we call a schema for the return data. So I am using this type object function, which is available from ellmer, and I can basically create my own sort of object type, which includes a name field, an age field, and a nationality field. I can specify what type each of these are. So the name is going to be a string, the age is going to be an integer type, and the nationality is also going to be a string type. So I can run that, and this is my type person. Okay, so this is my person type, and what I can then do is, instead of using $chat to ask my question, I can use the chat structured function instead. And here I can again pass in my user prompt, but I can also give now a return schema. I can provide this data type that I've just defined, and when I ask this question, the answer I get back is now going to be formatted as a named list in R, so I can access just the name if I want, or just the age if I want, which is pretty neat, right? So suddenly this output looks much more like something we can control. You know, it looks like this could be a consistent output, you know, every time we ask this question. So this is a way of getting around the randomness of large language models that I talked about earlier today. Now, we can also provide additional context. Some of this could be quite subjective. So, for example, all that the model sees right now is we want the age. But what age are we talking about? Do we mean Neil Armstrong's age when he set foot on the moon? Do we mean his age when he died? It's not clear. It's a very subjective, attribute to provide. So I could actually go back if I wanted, and I can redefine my data type. But this time I can pass in some clear documentation as to what I actually mean. So for the age, it is specifically the person's age when they set foot on the moon. And if I now ask that question again, we see now the age, which was 82, which I'm guessing was his age at death. It's now 38. Okay, so you can pass in additional instructions, additional context for exactly what it is you're looking for when you're asking these questions, which is quite nice. So we've seen how to set up an interface with a large language model of our choice. We've seen how to send user prompts and how to specify the system prompt. And now we've seen how to perform structured queries, so how to get back the output in a proper programmatic format that we can then work with. The only other thing I will show you in today's webinar is encoding images. So in my file space, I've also got this Safari JPEG image. So it's a scene from a safari. We've got various animals. We've got giraffe. I can see some elephants there. I can see some zebra. And if I go back into this demo, I can specify the file path for that image. So it's just safari.jpg. And for the chat function that we've been working with, there is also a function called content image file, and it basically allows you to provide an image along with your user prompt. So here I'm asking, what does the image show? And then using this content image file function, which comes from the ellmer package, I'm passing in the file path to the image. And here we are getting a very plausible looking response. So it shows a herd of zebras, we see elephants, and we see a giraffe. And again, we can combine everything we've looked at today. So how to get back a structured response, how to pass in an image, and again, we could use all this to get back a structured output if we wanted. So I could create a new data type called animals, or type animals. And because there are multiple animal species, let's say I want to have like every species, and for every species, I want to have the name, the weight, the diet, and the lifespan of that species. I can use a type object to specify all the fields I want for an individual species. And then I can put all of this into what's called a type array object. And this will basically give us, this is basically telling the model that I'm looking to find multiple animals from this image. So if I run this, and then I again can call my chat structured function. And here again, I'm using content image file to supply my image. I'm again using type to specify my object type. We can run this, and it's now giving me the information in the form of a tibble. So we could now parse this, and we can get all the unique species that are featured in the image. We've got the average weight of each species, the typical diet, the typical lifespan. So yeah, this is all useful information, but crucially, it's now formatted in the form of a table, so something that we can actually work with in our R program, which is quite nice. And just to add, it doesn't just have to be images. You could also use an LLM to summarize PDFs, or it could even be like a plot. So you might have a plot that you produced in ggplot for R, but you might want to reproduce that in matplotlib for Python. So you could basically ask it, oh, here's a plot that was made in ggplot. Could you give me the equivalent code in matplotlib to reproduce this in Python? And I've tried this myself, and they're actually very good at these kinds of tasks. So it's really good for like code migration tasks in particular. So yeah, that's everything really in the R side. I'll just very quickly show you that you can do all of this in Python as well. I'll not bother running the code here, but yeah, it's the chatlas package for Python is what we would use. And again, you can initialize your chat object. You can send user prompts pretty much in the same way. It's in a sort of Python syntax though, so we've got dots instead of dollars, for example, when we're calling these methods. Again, we can pass in system prompts. We can also define a unique data class. So on the topic of structured prompts, if we're talking about who was the first person to set foot on the moon, we can define a data class in Python for person, which includes name, age, nationality, and that's basically how we do this in Python. So this is the equivalent to the type object approach that we saw in the R examples. And again, in Python, you can also pass in images. So again, we've got this content image file function that we can use to feed in an image. And by defining data classes, we can get back the information in the form of, say, a pandas data frame or a Python dictionary. So an object that we can actually work with in our Python code. That's pretty much all of the content. I'm going to now go through the questions that have come up in the chat. Very quickly, though, I'll just leave you with a couple of closing slides, and I'll leave you with a link to our AI in Production conference, so you can start scanning that. So the packages we've covered today are ellmer for R and chatlas for Python. So you've got the documentation there. You can just search both of these online, and they're full of helpful tutorials and advice on how to use these packages and all of the features that are available. If you enjoyed this webinar, you might also be interested in our full day course, LLM-driven applications with R and Python. So it goes into the content that we've covered today in a lot more detail. And it also covers additional topics like how to create shiny dashboards that are powered by LLMs, how to set up a RAG workflow in R and Python, and also goes into things like safety, security, and responsible use of AI. So that's our brand new course, which is now advertised on our website. So do check that out and let us know if you're interested, or if your group is interested in that. If you are interested in our training offerings, you can use this discount code to get a discount off of all of our courses. So you can take a screenshot if you want to have that. And just to say, our next webinar is going to be on the 21st of May, and it's going to be a positive maintenance and support update being given by my colleague Seb. Just to leave you with this final slide, again, we've got an AI in Production conference taking place in June. So on the 4th and 5th of June, it's taking place in Newcastle. And again, it's a day of workshops followed by a day of talks on AI and machine learning. I did actually have a question about this in the chat asked by Tony. So I'll just answer that first very quickly. So yeah, with the conference, you can select 2 workshops for the workshop day. So you can select both a morning and an afternoon workshop. You don't just select one workshop. You can select 2 workshops for that day for the same price. You can choose whether you want a 2-day conference ticket, or if you just want to go to the workshops, or if you just want to go to the talks. So that's essentially how that works. So I'll leave up the link here, and if you want to scan that, please go ahead, and you can register now. And you've also got discount code JR-AIP-30 for 30% off. So I'll leave this up here so you can take a screenshot if you're interested in attending this later on. Cool. It is 2:00, so I know a few of you will probably have to go now. So for those that are leaving, thank you very much for coming today. Again, really appreciate the high turnout that we've had today. It's been amazing to see. But I'm going to stay behind now for the next 10 minutes or so just to go through the questions that have come up in the chat. Just to say, this webinar is being recorded, so if you do have to leave now, the recording should be going up on YouTube later on. So you'll also see my Q&A coming up then as well. Thank you, everyone. So just going through the questions, we also had a question from Hedia. Which LLM is better to use to solve bioinformatics problems? If I'm honest, I do not have any experience with using large language models to solve bioinformatics problems. What I would say, though, is I imagine that some of the more popular models we've talked about, like the Claude models from Anthropic and the GPT models from OpenAI, I imagine these models would be suitable, but you would probably need to give them access to some contextual information about bioinformatics, in order to get a reliable response. So if I was using these off-the-shelf models, I would probably look to set up a retrieval augmented generation workflow, or RAG workflow, where I give it access to some additional documentation and just so it has that more sort of domain-specific information. In terms of a package that you can use to do this, actually, there's a really great package called Ragnar. So I'll just type that in here. Ragnar, again, it's by Posit. It's free to install, and you can use it to set up a full end-to-end RAG workflow. So if you need to give your model access to additional domain-specific information, this is a really nice choice. If you're working in Python, then you can use Llama Index, Pinecone, or Chrome ADB. These are all really good choices when it comes to setting up RAG workflows. But yeah, I don't know of like a specific model that's just automatically designed to solve bioinformatics problems. I think you're always going to have to look for one that's either been trained specifically for those problems, or you would have to take an off-the-shelf one, but use a sort of RAG-like workflow, basically, so it doesn't hallucinate. Another question from an anonymous attendee: what difference would it make to use Ellmer or chatlas instead of Codex or Claude Code in your CLI? So with so ellmer and chatlas, these are both interfaces that we can use for interacting with a large language model. Fundamentally, though, it is still the same model that we're interacting with at the end of the day. And even if you're using an alternative to ellmer or chatlas, like like a Claude console, or if you're using a command line interface to Claude, it's still going to be the same model that you're interacting with at the end of the day. So the actual knowledge this model is going to have is going to be the same, across all of these, and you can expect to get back a very similar response. The specific features, though, that are available in ellmer might not be available across all other interfaces. So ellmer has these built-in tools that allow you to get back, a tabular format of the response, whereas you might not have that ability if you're using a different tool. So that's the only thing I would say. But yeah, fundamentally, it's still the same model at the end of the day that we're interacting with, regardless of which interface that we're using. So yeah, hopefully that helps answer that question. Another question that came up was, okay, so using ChatGPT, so someone has tried to use ChatGPT with ellmer, and they're using Chat OpenAI, but they're getting an error message, which is saying can't find OpenAI API key. So yeah, just a copy in the code that this attendee has been using. This is the code that they're using. So the code there looks great, by the way. That's exactly how it should look if you're using ellmer to connect with an OpenAI model. The error you're getting, just looking at that, this is basically telling you that you don't have an API key, or at least you don't have a key on your system that the model is able to detect. So I would add that key to my local environment. So if you're working in R, it would be the .r environment file, which is where your environment variables that are recognized by your R session, these should all be stored in your .r environment. And that will usually be in your home directory, like that. If you don't actually have a key, I would just refer to the OpenAI documentation. It should have a section on how to generate a key, and you can then just copy that key once you've got one, and you can store it under an environment variable with this name. So if you were to look inside your R environment file, you should have a line that looks like this, and you'll have some key, which will probably look like just a random sequence of characters, something like that. Question from Robert: can you suggest a model that provides the best output for generating QMD and YML files? The intent is to use existing R output, but create book or website format presentations. So I would say, so you're talking about Quarto reports or YAML files, or like YAML config files. So the great news straight away is Quarto and YAML, because they both look a lot like plain English. It's all just made up of words and text and so on. They're very good. AI co-pilots have a lot of success at outputting code that's like specifically designed for a reporting framework like Quarto. So whereas they might struggle with certain programming packages that haven't been around for a while, as long as they understand how to format a Quarto report, then the actual content it gives you should be pretty sound. In terms of the model that gives the best output, though, again, I don't know. Like, it's very difficult to say whether Claude or GPT is the best for producing a Quarto report. But what I would say is, if you are using like an AI co-pilot, so for example, I'm working in Positron here, and I've got something called Positron Assistant, and with this I can connect to any of these Claude models. So I've got this set to Claude Sonnet 4.6, just as an example. And yeah, as long as it's um, just from experience, I would trust Claude to be able to produce a quarter report for me, and to understand what the syntax should look like. I would just say experiment around, try maybe more lightweight models. You could start with Claude Haiku, which is probably going to be faster and maybe a bit cheaper. And then you could try Claude Opus, which is the more expensive, and you could see if there's a meaningful difference in the quality of the outputs that you're receiving. Um, but yeah, again, I don't think there is like a right answer as to which model is specifically the best for a quarter report or for a YAML file. I would just have an experiment around. But yeah, I would maybe try using GitHub Copilot or Positron Assistant or some framework that's designed for pair programming. And yeah, the models that are sort of available as default for those, they should be designed, I think, to have sufficient knowledge to help you with your reports generation. So yeah, I hope that goes well. Question from Amit: how does one use RAG with LLMs? So yeah, I've intentionally not gone into that topic in a lot of detail today, but yeah, essentially the steps that go into a RAG workflow are we basically gather information from the web. So that could be like a textbook, for example, that's freely available on the web. This is then converted into chunks, so labeled chunks of information. So every chapter of the textbook, for example, might be represented as its own chunk, and every subsection in that chapter might also be grouped into their own chunks. And what happens then is we take those text chunks and we vectorize these. So we create what's called a vector knowledge store. So this is basically like a numerical database which contains all of that information and that we have gathered. And again, crucially, it's kind of chunked. It's kind of split up into labeled chunks of information. And when we've got that store, we then produce what's called a retrieval tool. So it's something that can take a user prompt, and it can then go and retrieve the chunks of information that are the most relevant to answering that user request. So user sends a prompt, tool retrieves the most relevant chunks of information. Okay, and once you've got your retrieval tool, then you can register that with your chat object. So you can register tool with your chat object. So in this case, that could be your ellmer chat interface. It could be your chatlas chat interface. And basically, every time a user asks a question now, the very first thing that happens is the retrieval tool will be used to pull out the most relevant information from your knowledge base, and it will then add that contextual information to your user prompt and send all of that together to the LLM. So that's essentially how RAG works with LLMs. You're given access to some additional contextual knowledge. And if you set it up properly, then it should only be retrieving the most relevant information from the knowledge store. It shouldn't be using the entire content of the knowledge store each time, which would be very expensive. And again, Ragnar is a really good choice for this if you're working in R. And I've shown you a few examples for Python as well. So you've got Llama Index, Pinecone, and Chrome ADB are all pretty good choices for setting this up. Personally, I think Ragnar is the most straightforward for beginners because you can do the whole thing using just package functions. You don't have to install any other packages on top of that. So it's a very elegant package, I think, if you're new to RAG. And actually, yeah, check out the Jumping Rivers blogs as well, because I've actually got a blog on setting up a RAG workflow, which might be of interest. Just to go through these other questions, how does the sub prompt for each field in type work? Yeah, okay. So I think you're talking about this whole concept of defining a schema for our structured queries. So how does the sub prompt work? So the way that this works actually is quite interesting. So what happens initially is when we pass this data type that we've defined into our chat structured function, what happens is ellmer in this case will rephrase your prompt in such a way that it's able to get back a data output from the model. So generally what happens is ellmer will request a JSON-like output from the LLM that we're using. So the LLM will give us back something that looks a bit like this, where so it's kind of like a dictionary type of object where we've got the name, we've got say the lifespan, if we're talking about animal species. So that could be 25, name could be elephant or something like that. But yeah, this is what the model is going to give us back. And LLMs are actually really good with JSON data because they understand how it works for whatever reason with the curly brackets and everything, and it all looks kind of like plain English in a way. So it's quite a nice data format. So what's happening is we're getting a JSON format back, and ellmer is then parsing the relevant fields from this JSON-like object, and it's then putting this into the specific data structure that we have defined ourselves. So ellmer is basically passing an additional system prompt along with our user prompt to basically force the model to give us back the JSON-like information. So that question, going back to it again, it was asking how does the sub prompt work for each field. So the sub prompt, it's basically just again, ellmer is passing all this information. It's passing we want to have this object that has a name attribute, weight, diet, lifespan. And if we include this character string, this is also going to be sent to the LLM. So it's all getting sent as a single user prompt, but it's going to be quite a big user prompt because there's a lot of sort of contextual information that's having to be passed to it, so that it's able to know, that it has to produce a JSON data format as the output. But yeah, so essentially it's just adding to our user prompt, and that's really all that's happening here. It's just it's adding to the size of the user prompt that we're sending. But the benefit of that is we're then hopefully getting the correct values for each of these fields. Then we've got a question: can ellmer work with Copilot? Good question. So yeah, if we're talking about okay, what I would say to this is I would use Copilot or Positron Assistant or whatever tool you use. I would use these if I actually want a pair programmer. So if I want a model to produce code for me, I would just go with one of these options directly. To actually have ellmer work with Copilot, thing is you can actually ask ellmer, oh, give me the code to do such and such. So if I go back to the top of the script, I can say I can reinitialize that chat object, and I could say chat $chat. And even though I'm doing this within an R session, I could say, give me some example code to produce a pandas data frame, and I can run that, and it gives me some example code, as you can see here in the output, and it gives me a sort of toy data set that I can work with. It gives me the import for pandas. So that's completely plausible. That looks like it should work fine. So you can sort of use ellmer as a copilot if you want, but I would probably just use GitHub Copilot or Positron Assistant directly, if it's specifically code generation that I want to do, because the benefit of those tools is they'll be able to edit your script directly, whereas ellmer doesn't actually have the access to actually add text to your file, or it doesn't have the ability to delete lines or add new lines of code. So it's going to be a bit more involved, I think. And yeah, you might also be wondering, does Copilot know about ellmer? So could you use Copilot to give you help with ellmer? And again, ellmer is quite a recent package. So I think it's only about 2 years old. So the most recent models should be familiar with ellmer at this point, I would guess. If not, you could try giving it access to the README file for ellmer, and it will have all of the information that it needs there on how ellmer actually works. So you could try passing the README for ellmer as a system prompt, and then Copilot will hopefully then have access to that contextual information about how to use this package. Then we've got another question. Could you provide an example where RAG can contribute in the R or Python development process? Yeah, so if we're specifically talking about R and Python code development, I would say the best use for RAG is going to be to give your model access to information about the packages you want to use for your project. So you might be working on this project, but you have to use these very niche packages that maybe aren't as well known. So again, going through the steps I've discussed of maybe using Ragnar, the Ragnar package for R to set up a RAG database. The database in this case could be made up of, the README files from all these packages you're going to be using for your project, or you could give it access to the public GitHub repositories for these packages, and then you could set up a workflow that's able to parse the source code from these packages, add it to this knowledge store, and then yeah, you should have everything that you need. So if you're using a RAG to specifically contribute to R and Python development, I would say the best use case would be to, just give it. You might want to use it just to give access to the model to these packages that you're going to be working with, essentially. Another person has said thank you, and will you send us slides and code? So I do not actually have a public GitHub repository to send code, but we will be putting out the recording of this on YouTube after the session. So you can go back, watch the recording on YouTube. The actual code we've covered is actually quite bare, really. It's, most of this is just calling the same function again and again. So once you know how to, call that initial function to set up your chat, then you're pretty much good to go, really. But yeah, the recording should go up soon, so keep following us on LinkedIn, and if you signed up to this webinar, you should be on a mailing list, so you'll be kept up to date with what's happening in that regard. How to configure the cache to save tokens? That is a question I'm not so sure about, to be honest. I've not looked into how ellmer can be used to work directly with the cache for the model that you're using. I believe there might be something about this in the documentation, but yeah, I'm going to just have to say, have a look in the ellmer documentation or the chatlas documentation, and have a look there, and hopefully it should have some advice about how caching of tokens works. But yeah, that's a question that has come up in the past when I've taught this content previously, so it is a really good question when it comes to cost saving. But yeah, I don't know how to make use of the token cache with ellmer specifically. So yeah, definitely have a look into that though. It should be in the documentation anyway, if it is a feature of ellmer. Cool. I think we're coming towards the end of the questions. We have got a lot of questions, by the way. So thank you to everyone that has stayed behind for this. Hopefully this is proving useful. Could you use this to create a simulated data set, like artificial patient-like cancer data? Yeah, so I definitely simulating data is a use case for generative models. So there are generative models. I'm thinking of things like generative adversarial networks, which I've seen in the past or have been used quite often, where you've got, like, say, multiple images that all look like one thing, and you want to just generate some new images that also resemble that thing. And that process, I think, can also be applied to data sets. But yeah, I don't know exactly how that would work. I wouldn't probably use a large language model to create a simulated data set, because again, I don't think models are great when it comes to things like numbers and actually getting the statistical properties of the data set correct. So I would probably just, I would either just probably, I think there are off-the-shelf libraries available for Python and R which can help to create synthetic data for you. So I would just have a search of that, to be honest, and just see if you've got an option there. Yeah, I do not have any experience of using large language models to simulate data, but yeah, there's definitely off-the-shelf packages that you can use for that kind of thing. So I would have a look into that. When you use these APIs, does the content of your session get used for model training by the provider companies? Good question. If you're using a free tier model, so for example, Google Gemini free tier, if you look into the small print for that, it has something along the lines of you're basically giving Google permission to make use of your prompts for training purposes and for providing a better experience to you as a Google user. So if you're using a free tiered model, it means you're not paying the company in money. Instead, you're paying the company with your data, and the company will see everything that you are passing into your model, and it will use that to train and improve its products. So if you're using a free tier of a model, do not include anything sensitive because all of that will be visible, and can be used by the provider. If you're using a model that's a paid tier, then it should be more secure in that respect. Even so, I still wouldn't put anything sensitive into my user prompts. So I certainly wouldn't include any passwords or secrets or confidential data or information into my prompts. Because I think that that information is held by the company for a certain period of time. Um, it shouldn't be used to sort of directly train the model, but that it does that information doesn't just get binned at the end of a conversation. It does live somewhere, and therefore it could be hacked, or it could be accessed, by some malicious person. So yeah, I would always just be careful with maybe not using anything sensitive in your data. But yeah, if it's a free tier specifically, then yes, definitely it is seeing your data, and it will use this to improve Google services in this case. So yeah, just something to be wary of there. Can we do explainable AI in large language models using SHAP parameters? I do not know a lot about SHAP parameters, to be honest. And um, yeah, I'm not sure I can answer that question about explainable AI. I think you might be thinking about machine learning models. So I sort of think of large language models as being a separate class to machine learning. So if we're talking about explainable machine learning, then yeah, I think SHAP parameters can be used to give an idea of like how each input contributes to the final output from the model. But that's a different topic, I think. With AI, with a large language model, it's not designed to be explainable. We're talking millions of parameters when it comes to AI, when it comes to large language model. So it's going to be very difficult to know exactly why we're getting the answer that we're getting. But yeah, if you're talking about explainability in machine learning specifically, then yeah, I think I've come across SHAP parameters being used in that respect. So yeah, but yeah, I would say that's a slightly different topic to what we covered today. If you've got hundreds of text snippets that are in the same format that would need to be digested by the same prompt, can I submit by a loop text by text to the LLM? Okay, so there's a question on if you've got hundreds of text snippets. Yeah, you could use something like a for loop if you just want to submit the prompts one by one. That's absolutely fine. One problem with that is again, if it's all happening within the same conversation, then the input tokens are going to build up cumulatively each time. So your second prompt is going to include both the first and second prompts. Your third prompt is going to include the first, second, and third prompts. So it's going to ramp up costs, I think, quite quickly. So I would look into submitting all of the text in one go if possible, or initialize the conversation each time you're submitting a new text snippet if you don't need to have that full history being sent in each time. That's the only thing I would say. But yeah, absolutely. Every time you ask a question to an LLM, you'll be getting back individual text snippets back from it. So you can set up this kind of workflow. And then yeah, talking about Llama Index. Yeah, I don't know a lot about Llama Index, but Llama Index, it's a good choice if you want to look for. Yeah, Llama Index. It seems to offer a access to like lots of different providers and models, very similar to ellmer and chatlas. It also gives you access to embedding models. So these are the models that are used to map between the text and the vector representations. So yeah, there's a lot you can do with Llama Index beyond RAG, which I've talked about here. But yeah, I don't know a lot about those other tasks. I more know about Llama Index for RAG specifically. But yeah, there is also something called Hugging Face that I've seen as well, which is quite good if you want to just. I think Hugging Face has like a database of off-the-shelf models that have all been trained for different use cases and different domain-specific use cases. So that's another thing that's worth looking at. Cool. I think that's all the questions now. Apologies for anyone if my answers were a bit vague there. But yeah, I'm glad we managed to get through all of them. And yeah, thank you all so much again for coming today. And we've still got 44 participants who've stayed behind to the end of the session. So that's amazing. So yeah, just thank you all so much for coming today. And yeah, like I said, keep following us on LinkedIn. You'll stay up to date on any upcoming webinars and and news and courses that we're offering. And again, I'll just leave this slide up for anyone else who hasn't scanned this QR code for AI in production. Remember, you've got these discount codes as well for training and for the conference. But yeah, I'll leave this up now. And yeah, I think we'll just leave it there for today. So thank you all for coming, and I'll see you around.